real life.
So hi everyone. This is Arshia Mitra. I'm currently a PGP 1 year student of IIM Calcutta, and I've attempted CAT last year with 99.282 percentile, and I scored 99.94 percentile in Quants. So we'll be analyzing the Quants 2020 CAT paper in today's session. So I'm audible and visible, right? Really sorry, I got disconnected. So I'll be solving, as I was mentioning, I am a student, PGP 1 year student of Calcutta. I gave CAT last year with a 99.82 percentile overall and a 99.94 percentile in the quant section. And I'll be solving last year's slot 2 paper for quants. So I'll just be sharing my screen. Is this visible? So, first of all, going by the first question, so what I will do is that I will solve the questions one by one, and then I'll basically suggest about the strategies that I have learned about during my CAT journey, and the strategy that I followed during my CAT paper, and maybe some tips and tricks to help you calm down for the D-Day. So, yeah, we'll start. Okay, so this question is basically for polygons. So as we all know that the sum of interior angles for polygons is n minus 2 into 180 degrees, where n is the number of sides. So there are two polygons, A and B here, where the ratio of the sides is 1:2. and the ratio of the interior angles is 3:4. So basically what we can do in this case is that we can compare the interior angle. So what it typically will be that n minus 2 into 180 degrees. Let me know if in case it's not visible or by n. So for a regular polygon, each of the interior angles remains the same. So since there are n sides, so there will be n angles. And the sum of the interior angle is n minus 2 into 180 degrees. So per interior angle, it will be divided by n and divided by. So for the second polygon, it will be 2n because the side will be twice because of the ratio already provided in the question. 180 degrees by n. And the given ratio here is 3:4. So by 2n, sorry. So if we solve for n, and then we can find 2n because here the number of sides of B given is 2n we have considered. So if we solve for n, it will come out to be n equals to 5. So solving for 2n, which is the side of B, it will be 2n, which is equals to 10. Let me know if there's any issues with this question. If we go over to the next one, so just 1 second. Going over to the next question. So basically, this one is about 5 students, as I've already been mentioned. And including 5 students, including Amit, appear for an examination in which the possible marks are integers between 0 and 50, both inclusive. The average marks for all the students is 38, and exactly 3 students got more than 32. So basically, there are 5 students, of which one of them is Amit, and the possible marks can range from 0 to 50 anywhere. And average marks for all the students is 38. So in this case, we can find the total marks to be 38 into 5. Exactly 3 students got more than 32. Here it's given. And so the rest of the 2 students have got less than equals to 32. If no 2 students got the same marks and Amit got the least marks among the 5 students, then the difference between the highest and lowest possible marks of Amit is. So basically, if 3 students got more than 32, in order to find the lowest possible marks of Amit, we'll have to assign the highest possible marks to the 3 of the candidates who have scored more than 32. So in that case, we'll assign 48, 49, 50, which are the basically 3 highest scores possible in this case. We are also considering 50 because here it is written both inclusive. Okay. So 48, 49, 50 will be the marks of the 3 highest candidates. And so regarding the 3 others, basically this comes out to be round about 97 and 51, 47. The total is 190. So this is 147. So the sum of the scores of Amit and the highest one and the other one who has scored less than 32, it will basically be 52 here in this case, right? This is the score of Amit and the other 2. And they have scored less than equals to 32. So in order to have Amit score the minimum marks, he will have to assign maximum marks to the other candidate. So in that case, we'll assign 32, which is the maximum marks possible for the other candidate apart from Amit, who has scored less than 32, less than equal to 32. So we'll assign 32 to the other candidate and Amit will get 20 in that case. And here, basically, in order for Amit to have, just 1 second. So here it will be 20 plus 30. So Amit will get. And for Amit to have maximum marks, we'll assign the least marks to the other three. So in that case, we'll assign 33, 34, 35 to the other three, because the other three candidates have got more than 32. Here it is written. So since they are all distinct, we can basically assign them. 33 is the minimum possible mark. So 33, 34, 30. So it comes out to be 102. This is basically 80, 88. So for Amit to have the highest possible marks, it will come around to be somewhere around. So assigning the other three candidates to be 33, 34, 35, which are the minimum possible marks, comes out to be 102. But then the sum is 190, so 88, which is pretty much not feasible. So in that case, what we can do is, just 1 second. Yeah. So in that case, what he can do is basically when Amit scored, he can grab 20 marks, as I said, from the people who scored 40, 49, 50. And in the other case, we basically assign 31 and 32, which is the highest possible marks for Amit. Because like for Amit to have the highest possible marks, 32 can be the 32 can be the marks of the other person who has scored less than equal to 32 marks. And as it is already mentioned that Amit has scored 31 to Amit in that case. So because this condition, as we've mentioned, with providing 33, 34, 35 isn't working, because the other sum of Amit and the other second least scorer, it comes out to be round about 88, which basically is not possible because each of them has to score less than equals to 32. So in this case, we'll basically assign 31 to Amit, since he's the least scorer, and there's some person who has scored less than equals to 32 also. So we'll assign the second lowest scorer to be 32, Amit to be 31. And hence the difference here comes out to be 31 minus 11, which was in the previous case. And comes out to be 20. Regarding the next question, so in these type of questions, actually, we can do one thing. We can either consider some fixed volume X, but in that case, the calculation will be really cumbersome. So here, there are two containers, both having the same volume. The first container is half filled with sugar syrup. So half sugar, half water. Second container, half filled with milk. So half milk, half water. Half the content of the first container is transferred to the second container. Then half the mixture is transferred back to the first container, and next half the content of the first container is transferred back to the second container. So here we are basically repeating the same process thrice. So what we can assume is that we can assume the volume to be somewhere around half cube, because ultimately we'll have to multiply half 3 times. So we'll basically consider the volume to be a multiple of 8. So if we suppose consider this is water, this will be sugar syrup, this will be milk, this will be water. So if we consider this to be around about 80, the same volume it is mentioned. So it will be 80 water, 80 sugar syrup here, 80 water, 80 milk here. Half the content of the first container transferred to the second container. So basically here from here, 40 units of sugar syrup and 40 units of water will be there. So it will be ultimately 120 units of water, 40 of sugar syrup, and 80 of milk. Okay. And then we transfer half of the contents from the second container back to the first. So that's basically, again, so here what we have is 40 units of each now after the first transfer, right? Then secondly, we are transferring half of all the contents of the second container back to the first. So that will be pretty much 40 plus 60 units of water. Wait. So that will be pretty much 40 plus 60 units of water and 40 plus 40 units of sugar syrup and remaining 40 milk. Okay. So I'm just, this is water, sugar syrup, and milk in that order. And then finally here it will be then 60, 20. Okay, so this would be 40 plus 20 units of sugar syrup. I've written it wrong. 20 and 40. This is the current content. So this is then 100 water, 40 plus 20, 60 is sugar syrup, and 40 is milk. Okay. Finally, we'll again transfer half of this into the second container, which will roughly come around to be 60 plus 50. This will be 20 plus 30. And this will be 40 plus 20. And consequently, all the contents of the first container will also be halved. This will be around about 50. This will be 30, and the other will be 20. So that's basically water, sugar syrup, and milk in this order. Now we finally want the ratio of sugars, milk. as I mentioned, this is water, sugar, syrup, milk in this order. So it will be 50 by 60, which is 5:6. That is the answer. Okay. Who asked me if there's any question or any clarification? So regarding the next question. So here it was mentioned that there are two functions, fx plus f and g, basically. And so fx plus fx minus 1 equals to 0. And gx equals to x square. And here it is given that f of x square minus x equals to 5. We have to find the value of f of g of 5 plus g of f of 5. So here basically what we can do is that regarding these types of function questions, we usually replace x by, suppose in this case, fx plus fx minus 1. So if we replace x by 1 plus x, then in that case it will be f of x minus 1 will be f of x. So in that case, we can find again that f of x plus 1 plus f of x minus 1 equals to 0. And we usually solve it and then we go ahead with it. But in this case, basically what we can do is that we can, since we already know that fx equals to, we can basically write it in this way that fx equals to 1 minus f of x minus 1. So that will essentially mean that the value of fn, like we can basically replace the value of x to be x plus 1. And in that case, it will be f of x plus 1 equals to 1 minus f of x. So I'll just write it. So here we'll basically write it as you can already see, I haven't attempted it in the actual CAT. So yeah, equals to 1 minus f of x minus 1. Right? So pretty much if we replace this by x plus 1, then it will be 1 minus fx. Right. So here, basically what we can do is that for every value of fn, we can find a corresponding value of fn plus 1. Using the value of fn plus 1, we can then go ahead with x plus 2 equals to 1 minus f of x plus 1. And in that case, we can basically generate a series and we can ultimately find the value of fx. As I've previously mentioned that some way or the other, we have to replace the value of x in such a way that finally we get the value of fx for any real value of x. So here it is already mentioned that f of x square minus x equals to 5. So what can we write f of x square minus x? X square minus x is essentially x into x minus 1, right? So if we suppose consider f of x square minus x equals to 5, we can write it as f of x into x minus 1 equals to 5. Why are we writing it in this way? Because we have been provided with fx and fx minus 1 with a relation between fx and fx minus 1 in the question. So we have to essentially replace it while writing it. So here we can do one thing. Basically, we can write f of x into x minus 1 equals to 5. And then we can basically replace the values of each of the x's and find that which one comes out to be odd, which one comes out to be even. And in this case, we can solve it like that way. Because ultimately, we have to find out the value of f of g of 5 plus g of f of 5. So going ahead with the how I plan to solve it. Basically, if I go ahead with considering that f of 2 is 5, for example, putting x equals to 2. So f of 2 into 2 minus 1 will be 5. F of 2 is 5. So f of 3 we can find to be, so we are basically testing the values for which the answer comes out to be a odd number, which is 5. This is 5. Putting x equals to 2, it will come around to be f of 2 is 5, right? So f of 2 is 5. If we want to find us f of 2, so that will be 1 minus 5. So it will be minus 4. So that will be minus 4. If we go ahead with f of 4, then it will be again 1 minus minus 4, which is again 5. So in this way, basically a series will generate, right? So here we can see that for every odd number of x square minus x, we are getting the equivalent value of function to be an even number, and vice versa. For every even number, we are getting the equivalent value to be an odd number. So here, basically, in order to find the sum of f of g of f plus g of f of g of 5 plus g of f of 5, we can repeat the entire thing in such a way that it will basically come around to be g of 5 is 25, and f of 5 is, if we replace the value of 5 in f function, it will come around to be basically it will come around to be an odd number. So in that case, what we can do is g of 5 is going to be 25, as g of x is x square. So f of g of 5 is f of 25, which is essentially minus 4, because f of any odd number is minus 4, right? Sorry for, yeah. So this will come out to be minus 4. And in order to find the second part, which is g of f of 5, so f of 5, we are going to write it as minus 4. So g of minus 4 will come around to be minus 4 whole square, which is 16. So here we are writing f of 5 is minus 4. So basically g of f of 5 is g of minus 4, which is 16. And if we add these two, it will come around to be 16 minus 4, which is 12. So we are adding f of g of 5 plus g of f of 5, which is 16 minus 4, which comes around to the 12. That is the answer. Any clarifications or anything? Okay, moving ahead with the second question. Sorry, fifth question. So here basically what we mentioned is there are two ships that meet mid-ocean, and then one ship goes south, the other ship goes west. Both are traveling at constant speeds. 2 hours later, they are 60 kilometers apart. If the speed of one of the ships is 6 kilometers per hour, more than the other one, then the speed in kilometers per hour of the slower ship will be what? So in order to go ahead with this question, this is primarily Not even a trigonometry, primarily just a solving of equation sort of a question. So here we've been mentioned that after meeting, one ship goes south and the other ship goes west. This is west, this is south. Both have constant speeds, say v. 2 hours later, they are 60 kilometers apart. So basically, 2 hours later, they are 60 kilometers apart. So the length of the hypotenuse is 60 kilometers. Speed of one of the ships is 6 kilometers per hour, more than the other one, than the speed in kilometers of the slower ship is. So basically, speed of one of them is v plus 6 kilometers per hour. Speed of the slower ship is v. So in 2 hours, how much will the first ship cover? In 2 hours, the first ship will cover around about 2 into v plus 6, right? The faster ship. And the slower ship will cover 2v. So basically, we get the length of the base to be 2 into v plus 6. The other one to be v, 2v. Other one to be 2v. And basically, if we follow Pythagoras' theorem, then the square of a square plus b square equals to c square, where c is the hypotenuse and a and b are the other two sides. So we are going to solve for this equals to 60 square. So solving for this, we have to basically come up with the speed of the slower ship, which is v. That will roundabout come to be 18, which is the answer. So the next question is regarding quadratic equation. So 5x cube plus cx squared minus 10x plus 9, right? I just speed up a bit because I'm just in question number 6. So here what we can do is that we can actually put the values of r and minus r instead of x and solve for r. And so here primarily if we go ahead with 5r cube plus cr square minus 10r plus 9, right? Because it is a root, so it should satisfy the condition. This 9 equals to 0. And the same goes on for minus r also. So 5 of minus r cube. In this way, we are going to write the same equation. Plus c of minus r square is essentially cr square. Right? So in this way, we are going to write the same equation. Minus 10 of minus r plus 9. Okay. So if we solve these two equations for r, then we'll find out the value of r to be we'll find out the value of r to be plus minus root 2. So just plain and simple solving of simultaneous equations. So when the value of r comes out to be plus minus root 2, we'll basically have to find the value of c. So in order to find the value of c, we can do it in multiple ways, but in order to use a factor method in this case, so what we can do is that we can write it as x minus root 2 into x plus root 2 into x minus k, where k is the third root apart from plus minus root 2, because there's a cubic equation, so it is ideally going to have 3 cubic roots. apart from plus minus root 2. So we can consider it to be x minus k. And it should be equals to 0 because these are the roots, so it should satisfy the equation, right? So now what we can do is that we can basically solve for the value of k in this equation. So plain and simple, if we solve for the value of k, ultimately we'll find that the value of k comes out to be 9 by 10, and then we'll replace the value of k with the value of c because I'm showing you how. So if we elaborate this particular if we elaborate this particular factor question, we'll we'll find it is x cubed minus kx square minus 2x plus 2k. Just multiplying these three factors. So basically 2k comes out to be, 3x square comes out to be uh, equivalent to cx square in this case. So k is roundabout minus c by 5. If we compare both the equations, we can find that c by 5x square is equivalent to minus kx square. Just comparing the coefficients of x square in both the equations. And solving for the value of k, we got k's value is 9 by 10. So in this case, since c's value is minus 5k, so c's value should be 9 by 10 into 5. So it will roundabout come to be minus 9 by 10. I mean, this is plain and simple solving of equations. We'll like compare this to the actual equation provided. And in that way, we can compare the values of coefficients of x square. We can find the value of k to be something, and then this should be kx square, sorry. Kx square. This should be k not 3. Regarding this question, again, trigonometry. If this is a triangle, right? Altitudes AD and BE, AD and BE. These are the altitudes. So these are basically perpendicular to the corresponding sides. BAC is 45 degrees and ABC is theta. BAC is 45 degrees. ABC is theta. So we know that since BAC is 45 degrees, so in order to find we'll have to somehow incorporate the trigonometric functions in such a way that they incorporate these sides value whose ratio we want. So maybe sine 45 degrees. Sine is perpendicular by height, right? So for triangle BAE, sine 45 degrees will come around to be BE by perpendicular by hypotenuse. I'm sorry. So it will be BE by AB. And for the angle ABC, where B is theta, it will be sine theta. That is equals to, again, perpendicular by hypotenuse. So it will be BE by AD. So here, so basically here we are considering the triangle ABD. So sine theta will be perpendicular, that is AD by AB. AD by AB. Okay, it will be AD by AB. And we know that the value of sine 45 degree is half, sorry, 1 by root 2. So this is essentially 1 by root 2. And if we just divide the value of the second equation to that of the first, so AD by AB by BE by AB, so it will come around to be AD by BE. So that is sine theta by sine 45 degrees. So that will essentially come out to be root 2 sine theta. So we'll have to basically divide. This is 2, this is 1. Dividing 2 by 1 would give us AD by BE, that is root 2 sine theta. Let me know if there's any difficulty in any question. Okay, so regarding the next question, these are some of the questions that are very prone to mistakes by people, because the number of integer solutions, firstly it is theta, you don't get options for it, and people it's very easy to get it wrong. So basically, when something to the power of something equals to 1, what can be the possible cases? It can be that either, for example, if x to the power y is 1, then in that case, either x is 1 or y is 0, because we know that anything to the power of 0 is 1. Or it can be that x is minus 1 and y is an even number. That is basically minus 1 to the power of square, minus 1 to the power of 4, minus 1 to the power of an even number, basically, that will bring about an equivalent value of 1. So here we'll basically solve it in forms of cases. The first case will be when x square minus 10 equals to 1. So that basically gives us x square equals to 11. And x is not an integer in that case, so we are not going to solve for this particular case. The second one is when x square minus 3x minus 10 equals to 0, because anything to the power of 0 is 1. So in that case, this can be written as x minus 5 into x plus 2 equals to 0. So x minus x comes out to be minus 2 or 5, right? The third case, I'll just write the third case here. The third case, what I mentioned was that when x to the power y, in x to the power y, x is an even integer, and x is minus 1 and y is an even integer. So for that again, basically we'll have to write that x square minus 10 equals to minus 1, which roundabout comes to x square, x square minus 10 equals to minus 1. So x comes out to be 9. X square comes out to be 9. So x comes out to be plus minus 3, which are both integer values. But in this case, the power value should also be an even number, right? So if we ideally put the values of plus minus 3 in the power, then we find that it is an even number, because it's ideally x minus 5 into x plus 2. So if we put minus 3 or 3 in x minus 5, then it comes out to be an even number. So both of these values satisfy. previously we have got these two values also. So in total, we have 4 integer solutions, which is the answer. Regarding this question, I think it's pretty straightforward. It's just solving, of ratios, proportions. So there were 4 candidates. 80% of the registered voters casted their votes. One of the candidates received 30% of the casted votes, but other 3 candidates received the remaining casted votes, 70%, in the ratio of 1:2:3. But the winner of the election received 2512. So basically, one candidate got 30%. The other candidate got the remaining casted votes, that is 70% in the ratio of 1:2:3. That is basically 1/6, 2/6, 3/6, or half. So like 35%. And then there will be 1/6, that is 70/6. There will be 70/3%. I know in terms of percentage it looks a bit odd, but when we actually put in the values, it will be normal. I mean, it will for sure come out to be integer values. Right? So here, if the winner of the election here is 35%. So 35% of the casted votes. So if we consider the registered voters to be, suppose, 100x, the number of casted votes will come out to be 80x. And 35% of 80x comes out to be 2512, right? 35% of the casted votes is 35% of 80x. That will come out to be 2512. So in this case, we'll basically solve for the value of x, and ultimately we'll find out the value of 100x because the number of registered voters is 100x. So that will come around to be 62800. So here 35% of 80x, where 100x is the number of registered voters. So this is essentially 2512. Okay. Just solve for the value of x and find 100x. Okay. Going ahead with the 10th question. So here basically we have a plus 2b equals to 6. So here there are basically 2 ways to do it. First way can be when we actually put in integers, like for example we put 0 and then we put b equals to 3. We put a equals to maybe 0.5, and then b 2b will come around to be 5.5, and b will come around to be 5.5 by 2 basically. We put a to be 1, b will come around to be 2.5. If you put a to be 2, suppose, then b will come around to be 2 again. If you put a is 6, b will be 0. So we can see that as I'm increasing the values of a, the value of a plus b also is increasing, right? So like this was 3 in this case, 4.5 in this case, 3.5 in this case, 4 in this case, finally 6. So if I have to put the value of, find the maximum and minimum values of a plus b, then in that case, we'll have to basically put minimum value of a in order to have the minimum value of a plus b, and vice versa, right? Because why this happens is basically of the coefficient of b. So here we find the value of minimum value to be 3, maximum value to be 6, and the average to be 6 plus 3 whole by 2, that is 9 by 2, that is 4.5. The other way to do it is basically to have something like a plus b equals to 6 minus b, to write it in this format. So pretty much when b, so when b is suppose 6, which is not possible. When b is 3, then it would be 3. The maximum value of b can be 3, and the minimum value of b can be 0. So when the minimum value of b is 0, a plus b is 6, right? Because a plus 2b is 6, so 2b should be less than equals to 6 for b to be an integer, non-negative integer. Since it is non-negative, it can also have 0. So in that case, because of this, I also considered these two extreme cases of a and b to be 0, right? So this is done. Regarding this question, for some natural number n, assume that 15,000 factorial is divisible by n factorial whole factorial. And we basically need to find the largest possible value of n in this question. Again, this is a bit intensive when it comes to knowing the way to do it. So if we consider n factorial to be, suppose, any number k, because factorial just makes it more complicated. So if we consider n factorial to be any positive number k, so in that case, we have to basically find the value of n such that k factorial divides 15,000 factorial, right? So in that case, if it divides 15,000 factorial, the maximum possible value of k factorial can be 15,000, right? And I mean, the maximum possible value of k can be 15,000 for k factorial to divide 15,000 factorial. So pretty much the maximum possible value of n factorial can be 15,000 because we've replaced k by n factorial. And now if we basically find n factorial less than equals to 15,000, our purpose will be solved. So here we can see that n factorial to be less than equals to 15,000. We have to put these values to see which one is sufficing our condition. If we put n equals to, for example, 4, because 4 is in the option, it is 24. If we put n equals to 5, is 120. Put n equals to 6, it is 720. So if we put n equals to 7, it is 5040. But as soon as we put n equals to 8, its value will be 5040 multiplied by 8, which crosses 15,000 for sure. It is somewhere more than 40,000 also. So here, I mean, 8 we need not check because in the options, the maximum value is 7, which is already satisfying. So the answer would be 7 in this case. So in certain cases, we can also look at the options first before, jumping into the solution of it. Regarding the number of integers greater than 2,000 that can be formed with the digits 0, 1, 2, 3, using each digit at most once. So using each digit at most once essentially means that it can be either used or not used. So if we go ahead with plain and simple finding the values, it will be greater than 2,000, right? So starting with maybe 4-digit numbers, okay? If I put 2 in this case, the number of integers greater than 2,000 that can be formed. So I can basically put 0, 1, 3, 4, 5 in the other 3 places. In how many ways? 0, 1, 3, 4, 5. 5 numbers. So in this case, how essentially we do it is we calculate the probability of choosing one number using permutation combination. So choosing one number from the remaining five numbers is 5C1. Choosing there are four remaining numbers. Choosing one number out of them is 4C1. Choosing one number out of the remaining three is 3C1. Since they can only be chosen at most once, it will be 3C1. Okay. The same thing will be repeated for when it is starting with 3, when it is starting with 4, right? As well as when it is starting with, so here basically it is given that the number of integers more than 2000. So calculating this value, it comes around to be 5 4s are 20, 3s are 60. So for 2, 3, 4, 5, this will be multiplied by 4. That comes around to be 240. These are all the 4-digit numbers which are possible. Calculating the 5-digit numbers, it can, when we calculate the 5-digit numbers, it cannot start with 1 for sure. So it can only it cannot start with 0 for sure. So it can only start from 1. So in this case, it can be 1, 2, 3, 4, 5, which are 5 values. So this can be like 5C1. And we follow the same drill for the rest. But in this case, for the next number, it should be 5C2. Okay. Why 5C1 again? Why 5C1? Because here, from the second digit onwards, we can incorporate 0 also, which we haven't taken into consideration previously. So 0 can start from the second digit. It cannot occupy the first digit because in that case, it would essentially be a 4-digit number. So the same thing we can again do for a 5. This is for a 5. So we can do for a 6-digit number also. It will not start with 0. It will basically start with 1 to 5. And we'll multiply whatever number we get by 5. So like here it can be 1, 2, 3, 4, 5. So whatever number we get from 5C1 into 5C1 into 4C1 into 3C1 into 2C1 like this, we'll multiply it by 5. Okay. And the same thing we are going to do here also. Here, this is going to start with 1. So there are 5 numbers, 5C1 till last one, it will be 1C1. And we will multiply it with 5 because the first digit can be 1, 2, 3, 4, 5, anything. This has to be 2C1 because there are 5 digits. So only 1 digit will be left. We're going to add all the cases and calculate the value, which will come around to be 1440. I'm not going into the calculation part of it because of time constraints. So the average of a non-decreasing sequence of n numbers. So again, this will be purely based on formula. So like A1 to AN gives us 300. And then 6A1 to AN gives us 400. So pretty much we can calculate for the value of 5A1. Right? So A1 to AN gives us 300, right? The average. And 6A1 plus A2 plus dot AN gives us to be 400. So here what we can do is that the plain and simple thing that we can do is if we find the value of A2 to AN in each of these cases, it will come around to be 300 minus A1 in the first case and 400 minus 6A1 in the second case. So if we equate both of them, we can find the value of A1, right? So like 300 minus A1 comes around to be equals to 400 minus 61. So solving these two, we get okay, and also there's an n here, which I forgot to mention, because this is the average. So this will be n. So here, basically, A1 comes around to be somewhere around 20n. And since A1, I mean, the average can be less than, I mean, till 300. So it's essentially an increasing sequence. So essentially, 20n has to be less than 300, which gives n less than 15. That is, only 14 values of n are possible. Because it is mentioned that it is a non-decreasing sequence. So A1 cannot be 300. A1 has to be less than 300. Going to the next question, it essentially mentions that the number of integer distinct integer values of n by log base 2n minus 3 minus log base 4n has to be less than 0. So this essentially, so if we go by the formula for log, log of base 4n is log of, we can write the 4 to be log of base 4n is essentially log of 2 square n, right? Which is essentially half of log base 2n, right? Okay. So we'll have to find the number of distinct integer values of n which satisfies this condition. So if we consider log of base 2n to be something, for example, say x. So 4 minus x by 3 minus x by 2, essentially. This has to be less than 0. So if we, without solving, if we just visualize, so for any value of x, so log n of 2 is x, right? So for any value of x less than 4, this will come out to be, the numerator will come out to be negative and the denominator will be 3 minus, this is less than 4. So 3 minus a positive quantity. So this, the numerator is positive, the denominator is negative. So we get a negative value. And for any value of n, so log of n greater than 6, it comes around to be 4 minus 6, which is negative quantity in the numerator value and negative quantity in the denominator value also, which ultimately gives us a positive value. So essentially what we have to do is that for x less than 4, for x greater than 6. So this is essentially not, the condition is essentially not sufficing for these two equations. If you just plain and simple put the values of these two equations, it will not hold true. So essentially the value of x should be anywhere between these two numbers. So x should be between 4 and 6. That basically gives us n to be between 16 and 64, because we've considered log of base 2n to be x. So in that case, it will be 2 to the power x, right? N will be 2 to the power x. So the number of possible values of n will be, in that case, 64 minus 16, which is 47. Right. The next question is a plain and simple investment sort of a question. Again, calculation and all of that. 1/5 of his capital at 6%, 1/3 at 10%, and the remaining at 1%. Simple interest, we know the formula. It is PRT by 100. The minimum number of years required for the cumulative interest income from all these investments to exceed his initial capital. This is purely based on formula. We consider an initial capital to be somewhere around, say, 100x. And 1/5 of his capital at 6%, 1/3 at 10%, and the remaining at 1%. Calculate the interest values, and it should at least be greater than equals to 100x. Solve for x, and we get the value. So in each of these simple interest values, we will basically get a fixed number of, say, t. For t years, he's kept it there. So even if x, so we'll basically have to solve for t, because x will get cut from both sides when we actually put in this formula that each of these, so the sum of these three interest values has to be greater than equals to 100x. So x will cut, we'll get solve for the value of t, which is required. It will come around to be 20. So again, this question is another average based question. So here it is mentioned that Manu earns 4,000 per month, and he wants to save an average of 550 per month in a year. First 9 months, the monthly expense. So 4,000 per month, if we maybe consider, say, for 12 months. For 4,000 a month, earning, he wants 50 per month. So we round about 3,450 of expenditure for 12 years, for 12 months, that is a year. In the first 9 months, his monthly expense was 3,500. For the 10th, 11th, and 12th, his monthly expense will increase to 3,700, right? In order to meet his yearly savings target, his monthly earnings in rupees should be. So we know the yearly savings target is around about 12 into 550, that is around about 6,600. So we know the total expense to be 3,500 for the first 9 months, and 3,700 for the rest 3 months, since we've considered a 1 year period. So this will be his total expense. We know the total savings. So basically, since the earning for the first 9 months is around about 4,000. So the earning, this should be the actual earning that should be in the ideal case. Ideal for the first 9 months is 4,000, that is 36,000. For the remaining 3 months, we can consider the earning to be x. So 3x plus 35, 3x plus 4,000 is, for the first 9 months, it is 36,000. You're basically equating these two. Find for the value of x. Okay. So see, in this case, on day 1, there are 100 particles. On day 2, on day n, where n greater than equals to 2, one out of every n particles produces another new particle. So basically 100 particles on day 1. On day 2, it will increase by 1 by 2 because 1 out of every n particles. So for day n, for day 2, n is 2. So the increase will be half of 100, that is 50. Right? So the total will come around to be 100 plus 50, that is 150. Also writing the totals here. For day 3, it will be 1 by 3 into 150, and it will go on like this. Okay. We are noticing that for each of the cases, the increase value is the same, which is 50. So for basically how much number of days should it increase so that the total number of particles increases to 1000 on day m. So it should essentially be 100 plus 50 into n, like 100 plus 50 into n, which n is the number of days. That should essentially be around 1000. No, wait. So this is going to be 100 plus the increase is 50 for each day. So the increase should be 1000. So, okay, in this case, at the rate of increase of 50 particles per day, it has to take around about 18. Right. So here n should be 18. But here we are counting it from day 2. So we'll also have to take into consideration day 1. So the total number of days will be 18 plus 1, which is 19. So essentially, I should have written 15 to n minus 1 in this case, if I have to also include day 1 in the equation. But you can do either or. So working along times taken by Anu, Tanu and Manu, it is 5 is to 8 is to 10. So basically the efficiency in this case will be 1 by 5 is to 1 by 8 is to 1 by 9. And essentially, so for the first 4 days, we can basically take uh, LCM, multiply it by it, multiply each of these factors by it and come up with the equivalent efficiencies. So for the first 4 days, if we consider this to be somewhere around yeah. So if we consider this to be a fraction, so 1 by 5 is to 1 by 8 is to 1 by 10. So it will round about, sorry, I wrote this thing wrong. It should be 10. So the ratio of the efficiencies should be, if you multiply this by 80, so it will be around about 16. If you multiply it by 40, suppose, it will be 8 is to 5 is to 4. Right? So the efficiencies are 8x, 5x, 4x. 4, if all of them work for 4 days, they will complete the work at 8 hours per day. So 4 into 17x into 8 is the total in that case, total work done. For the first 6 days, working at 6 hours, 40 minutes per day, Anu and Tanu. That is 13x for the first 6 days into 6. This is the total work. Okay. This is the total work. This is the total work. So this into 6 hours, 40 minutes. This has already been the work that is done. The total work left is this minus this. We calculated number of hours that Manu will take to complete. Manu's efficiency is 4x. So we'll ultimately divide whatever we have by 4x. The number of hours, and then it will ultimately come down to be 6. So consider the arithmetic. This is basically your aim to know the sum of the first n terms of this progression. So we will do up to 25 divided by 25. Right. So sum of first n terms of an arithmetic progression is n by 2 into 2a plus n minus 1 into d. It's pretty much plain and simple formula based. N is 25, d is 4, a is the first term, that is 3. So n by 2 into 2a plus n minus 1 into d. This is if we put n to be 1, that is the first term. If you put n to be 2, that is basically the sum of the first two terms. In that case, we'll basically go ahead with the addition. And addition also, it will either come under AB or GP or AGB. And then we can solve using the formula and divide the entire summation by 25 to get the answer. Regarding this question, the length of each side of a equilateral triangle is 3 centimeters. Let D be a point on BC such that the area of triangle ABC is half of the area of triangle ABD. Okay. So this is basically half of this. So this is 2x. This is x. 3x is root 3 by 4 into a square. That is the area of a triangle having side as a, equilateral triangle. Root 3 by 4 into a square. A is 3 in this case. So this is basically 9. Right? So 9 root 3 by 4. And then so we can find the areas of this triangle also. In this triangle also. Then the length of AD in centimeters is in many ways. The first way in which we can do this is basically if we from the value of the areas that have already been provided, if we actually back calculate in order to find the by putting in the value of area of a the formula of area of a triangle having sides ABC. So in that case, what we can do is that we can plain and simple put like somewhere here. You can do it. So that will basically bring about half of, so in order to calculate the area of AEC, we have half of AE into CE. C is suppose X into C. And then we have half of AE into BE, where BE we can write as BC minus CE. That is essentially 3 root 3 by 4 minus X. Right? And we add it, and then we equate it with the total area of the triangle, that is root 3 by 4 x square. Right? So in this case, again, another way in which we can find the value is basically half of AE into BC equals to the particular number. So half of AE equal AE into BC, BC's value we know. A we can find because half of A into BC will be equals to the area of the equilateral triangle, that is root 3 by 4 into A square, where A is 3 root 3 by 4. So once we have the value of AE from there, we can pretty much put it here. So this will be C in this case, right? Because CE is BC minus BE. We can put it here. This is equals to the area, right? The area value we know. A's value we got from half into base into height formula. We can get the value of CE. If we get the value of CE, we can pretty much get the value of all of these, like AE value we already have, CE value we already have, AC we have already. So AD, we can then find out from the triangle ADE, where AE value we know, DE value we can find from BE minus BD. And then we can put Pythagoras' formula in the triangle ADE, where AD square will be equals to DE square by AE square, and it will come around to be root 7. So ultimately, after finding the value of AE, we'll have to put the Pythagoras formula in ADE by finding the length of DE, and after we put the formula, we'll get the length of AD also. Okay, so last two questions. Let fx be a quadratic polynomial in x such that fx greater than equals to 0 for all real numbers x. If f2 equals to 0 and f4 equals to 6, then f minus 2 equals to what? So in typically these type of questions, how we solve it is, I mean, again, there are many ways to solve it. Some can actually put in values to check which one is satisfying, which one is not. So you can basically take a dummy value, like take a dummy quadratic equation. Suppose any typical quadratic equation will be of the form ax square plus bx plus c. And since it is already been mentioned that fx greater than equals to 0, so ax square plus bx plus c should be greater than equals to 0. Now, f of 2 equals to 0 and f of 4 equals to 6. So if we pretty much put the values of 2 and 4 in this case, so fx is ax square plus bx plus c. Right? So here it is already mentioned that f of 2 is 0, f of 4 is 6. So f of 2 is 4a plus 2b plus c. That is 0. And f of 4 is 6. So then putting the value of f of 4, it will be 16a plus 4b plus c. That is equal to 6. So now essentially we have two equations. We have three unknowns, a, b, and c. So what we can do is that we can actually solve for if we draw the graph in this case. So it will typically look like a parabola, something of this sort. So essentially this means that f of 2 minus k for any x equals to 2 minus k. So it will be symmetric across the y-axis. So that essentially means that f of 2 minus k is equals to f of 2 plus k, because the graph should be centered at x equals to 2, right? So going by this formula, going by this logic, f of 2 minus k for any x equals to 2 minus k, because the graph is centered around x equals to 2, it should be round about f of 2 plus k. So essentially, if we put k equals to 2, it would be f of 0 equals to f of 4, that is 6 in this case. And if I have to find k equals to 0, then f of 2 equals to f of 2 anyway. So the third equation we can write here in this case is f of 0 equals to 6, putting k equals to 2 in this case, right? So 1, 2, 3. We have three equations, three unknowns. We need to solve for the values of a, b, c by simple formula. And ultimately, we can find the value of f of minus 2 also. Right? The last question here is, in an examination, there were 75 questions. 3 marks were awarded for each correct answer. And 1 mark was deducted for each wrong answer and for each unattempted question. Ryan scored a total of 97 marks in the examination. Number of unattempted questions was higher than the number of attempted questions, and the maximum number of correct answers that Ryan would have given in the examinations. So 75 questions, 3 marks were awarded, -1, and 1 marks were unattempted. So suppose 3a minus 1 into b plus 1 into 75 minus a minus 2. This is essentially 97. We need to find the value of maximum value of questions that Ryan has attempted. That is basically maximize the value of A and B. So here, what we can do is that we'll basically generate one equation in terms of A and B, and we can put dummy values for each of A and B and search for the highest value, putting integer values for A and B. And so essentially this will come around to be 2a minus 2b plus 75, right? So this is essentially 22. A minus b is 11. So what we can do is we can put dummy values in both of them. Like for example, if we put then B should be 9, but we have to maximize A plus B also simultaneously. So the objective is to maximize A and B, A plus B. So solving for this, we'll get A minus B equals to 20, A minus B equals to 11, and putting dummy values in order to maximize A and A plus B. We'll get the such that it also satisfies this condition that the maximum number of questions should be less than equals to 75. So in this way, we can do the, yeah. One question, okay, so I'm done with the solution. One question that is posted is, ma'am, how should we improve our speed? Should we skip questions that look lengthy or give some time to every question? Yeah, so basically, coming to the strategy, there are basically many strategies followed by many people depending upon how convenient it is for them. One thing that they can do is basically split the entire section for a 2-hour slot. It will be 40 hours for the quant section, right? So split the entire quant section into groups of 10 minutes each. For the first 10 questions, aim for the easiest question that you can solve at the very first glance. So at least try to do 6 to 7 easy questions in the first 10 minutes of the slot, right? In the next 10 minutes, you can basically go ahead with solving some of the questions that you know that you can solve, but it will take some time to calculate and come up with the answer, but you have done it previously, so you know the method. And so this you can do for the second 10 minutes or maybe 10 to 15 minutes. Like if I say 10 minutes, there's basically a pretty much plus minus 3 minutes gap buffer. Regarding the third 10-minute slot, you can actually go ahead with some of the tough questions and which you have seen previously, but you haven't yet solved. But you have seen others, you have seen basically known the method, but it will take a lot of time. Or some questions that you know you can't solve, I'll suggest you to have a look at it at the end, last 5 minutes, or leave it if time doesn't permit. So ideally, you should glance at the entire paper and demarcate each of the, like write on your the scribe that will be provided to you, write the number of questions segregated as per the difficulty level, write the question numbers like easy, medium, hard, and aim for the easy questions first within the first 10-15 minutes maximum. Try to do at least 6-7 questions. Then the medium, another maybe 5-6 questions in the next 15 minutes, and which will leave you with another last 10 minutes roughly. So in that case, you can go ahead with the hard questions. And regarding the hard questions also, at least try to do the familiar ones first, like which you have seen, rather than going ahead with uncomfortable topics and not solving any. On the D-Day, please tell us a strategy to attempt the quant paper. Any strategies related to number of questions to be attempted within a specific time? What was your strategy? So the strategy that I followed in the D-Day was pretty much, so I went into the, exam day thinking that I'll follow the strategy that I mentioned. But at the end, to be very honest, I ended up solving each and every question as it, went ahead with the flow. In the last 5, I mean, couldn't solve the last 5 questions because, of the speed issue that I was facing. But then ideally, whichever questions I solved around about 17 questions, 18 questions. And since the quant paper was a bit easy for our slot, it got scaled down. So ultimately, I scored around about a bit more than 49 in the scale scored part. But so I basically went on solving as with the flow, every question as it came in the order that it was in the paper. But the strategy that should ideally be followed is to demarcate the questions based on the level of difficulty and demarcate the time in 10 to 15-minute slot, starting with the easy questions, then second round with the medium questions, and then third round with the difficult questions. So try to note down which questions are of which level so that it is easier for you to directly go to the question without clicking on next every single time. It will also save a lot of your time because ideally the mouse is a bit not that good to deal with, that is provided in the CAT exam. Regarding the speed, I think many people would suggest us to memorize the multiplication tables and all of that. But I don't think that's, I mean, that does help in the calculations. But what ended up happening with me was that I ended up, even 2 plus 3 equals to 5, I would have to calculate. Like the pressure builds on so much. And in my case, my VRC didn't go that well. I was confident with the iler and Quants, but there was a bit of pressure on me also. So the last tip that I will give you all is to just maintain your calm. Even if one section goes very bad, like VRC did for me, I didn't let the pressure go on for the iler and Quants sections. So yeah, all the very best. Feel free to reach out to me. You can reach out to me on LinkedIn also, on any other platform, and I'll try to guide you as much as possible. I'll end the session here. Thank you so much.